Hello, my name is Arham, and my topic for my FYP is blockchain usage in the farming industry. This is my FYP 2 progress video number 2. In my last update, I was still in phase 1 and I was working on the code for the flow state class. And from then on, I have now completed everything in phase 1 from A to G. And I'm currently working on phase 2, which is creating the database, building the server, connecting to the Corda's greater network of blockchains, which is the through API, connecting the code to the API test, and then the database to API test. And at the same time, I'm working on the front end. I've designed mock versions of the wireframes, and at the same time, actually coding out the front end currently. Now onto the code. In order to run the code itself, we open git, and the first command we put into git is /gradlew deploy nodes to start running the cord app. Once this command is put in, you'll see the following scripts appear onto the terminal. And you can see that the build is successful. Now if you open IntelliJ, you'll see the following. You'll see the node driver displaying all the nodes in the cord app. In IntelliJ, you can see the various classes that I have coded. The first one you see is the token flow initiator class, which is then followed by the token issue flow responder. Then we have our token state. This is where a lot of the work happens, especially for our states in general, where we define a shared fact on the ledger itself. We then have our token contract class, which is basically our contract for the entire cord app. This governs how our state will evolve over time. Okay, then is the integration test class. This class was used to go through various tests to see if our code was working correctly or not. After that, you can see that I'm working on the RPC. The RPC is needed to go with the API in order to connect the front end to the back end and the servers in the database. Next, you'll see the flow test class, and as you can see, there are a lot of tests that we go through. Furthermore, we take a look into the build.gradle file. This will give you insight on how Gradle works in IntelliJ, and it shows all the various things that it brings in to manage the project itself. Next, you can see the node configuration. The node configuration, we tested it with some hard-coded values in order to see if the actual cord app would work or not in terms of the transactions. Now, if you go back to the code itself while it's running, the cord app, you'll see the various nodes. The first is the farmer node, then it's followed by the market node, then it's followed by the processor node, which is then followed by the delivery node, and then the notary node itself. That is a total of 5 nodes. So for now, let's run a transaction. And first of all, we'll see the flow list, which shows us what kind of commands we can run. Next, we run our first command, which is flow start bootcamp.token issue flow initiator. There, the market pays the farmer 50 units in payment, and from there we will send a token, and then once it is verified on both sides and the transaction is complete, the farmer will send the goods to the market itself. That command was run in the market node. Then the following will appear, and this would also be in the market node since the market initiated the transaction. You can see that the signatures will be collected from all parties involved. Once the signatures are verified, the transaction will be broadcast to the participants. Now that we verified the token, we can go back to the market node again, and as you can see on the top left at 11:15 and 18 seconds, we run the vault track to verify the transaction. Now that we've checked at the market end, we can also go to the farmer node and see from the farmer end that if the transaction is complete. So as you can see on the top left, on October 8th, 11:16 and 49 seconds, I run the vault track again on the farmer node to verify if the transaction has been complete. As you can see, between both parties, they both can verify that the transaction has been complete. Now let's see the sanctity of the transaction. We can open up another node like the delivery node, and if we run the vault tracker, we can see that it cannot see anything that happened in regards to the transaction between the farmer and the market. it cannot see anything at all. So the information of that transaction stayed only between the farmer and the market nodes. The delivery node knows nothing about it. That pretty much completes my progress video too, but in regards to the work that I've done so far, if I mention one of the challenges faced, as you can see, all 4 nodes are running on one PC. This was a technical challenge I had to face, as my own personal computer was lacking, as there was only an i5 with 8 GB RAM, so I had to borrow a laptop with i7 and higher RAM in order to at least simulate what I'm doing. And in regards to another technical challenge or circumstantial challenge, because of COVID-19, I was unable to access or have free flow access to the campus laboratory and resources, due to which at the moment why I'm running all 4 nodes on one borrowed laptop. So that is a technical challenge that will need to be overcome with time. Thank you for watching.